I never understood the speed of high-speed rail. The electrician above. How does it keep the power on? I want to understand the principle. It starts with his evolution. The early ones were not called electricians. It's a stick with a spring against a wire. Transmit current to the motor. Drive the wheel to turn. The contact surface is so small and it falls over easily. That's definitely not possible. Must change. Install the stick diagonally. You take the spring to the side and you pull the stick. But something more serious happened due to the unstable force of the spring, causing the stick to go up and down. This state can even break the wires. And here's how you do it. Add a pull wire on the other side of the stick. That way it won't move. Then a copper groove is installed on the head. The wire just got stuck in. It feels perfect, but I can't run anymore. Can't withstand friction at all. Can't run for a few days. This groove is not worn like it is. We can only continue to improve. I'm going to use two sticks and a crossbar. In fact, the wires on it are squiggly. Someone asked how long the real weight is. Is the wire above one to the bottom? We'll talk about that one last time, since the thread is curved. This way it won't rub in one place. Then they added carbon strips to it. It's more durable. It's okay to run to 100 kilometers per hour, but it won't work any faster due to air resistance and vibration can lead to poor contact. Engineers came up with a new structure in 1903. The middle spring controls the height of the electrician. It's powered by the pneumatics underneath. The driver can observe the tightness of the line to control its lift. This diamond-shaped structure greatly reduces air resistance and vibration. It feels perfect at this point, but he was big and heavy. Driver control again, so it still doesn't work. Worked in 1955. Engineer Louis got welfare out of the single-arm pantograph. It's just a really simple-looking arm. Has been used until now. The bottom half is a 4-bar linkage structure. When moving up, the yellow part will change a certain angle. Transform. Extend it. Put the head on the contact plate and you're done. But the contact plate will tilt with the height. This can also lead to poor contact. I didn't expect to add a balance bar below. It's solved. When you descend, the distance between the ends of the balance becomes smaller. It will push the contact plate to move slightly. Keep your balance. When it rises, it will pull the contact plate microstrip again. This will always keep the contact plate balanced. It's this simple structure. Solve the air resistance problem. The force through the spring during operation. Automatic adjustment of contact status. The lower arm is connected to the pneumatic device. Yes, when necessary. Completely bring down the electrician. As mentioned earlier, is the line aligned to the end? No, definitely not. It's all connected. Due to thermal expansion and contraction, wires will sag. This will definitely affect the operation. You may have seen it too. There's also a string of counterweights next to the pole. This is to tighten the wire through the pulley device. If the distance is too long, the counterweight is fast and the effect is not very good. Then put a pole in the middle. You can also add another establishment lock on it. Fix it with a connecting rod in the middle. Play the role of pulling up. It can also serve as a backup power supply, so there's a lot of wires connecting them. Each segment has a connector. That's the structure. Electricians are longer. Contact at the joint at the same time. This way the power will not be cut off.